Good morning, good afternoon, or good evening, depending upon where you live around the world. This is an introduction to this set of videos that will be generally headed up as Dome, and I wanted to just give a quick overview to indicate perhaps the information that's going to be held within it and its worth for persevering. What happened with these videos was it was a true revelation for me. I came to it trying to draw within SketchUp an accurate representation of a dome that I wanted to build. Therein started the issues. I wanted to build I'm going to call it a non-conventional style of dome, the one which has four corners essentially, and instead of the more circular versions that we think of as being domes. The information for that wasn't readily available at the time and still isn't to my satisfaction. So the information I've created it's not unique, but it is just this side of being rare on the internet. And I thought that maybe other people would like to share with some of this information, perhaps, and gain benefit from it. However, and this is the point for this short video, there are many of the video which I am going to consider leaving in the series that are dead ends. In fact, some of them are not only dead ends, they are total reversals, having very little benefit to the watcher or the budding dome builder. However, I want to keep them for consideration, not for posterity at all, but for people to see the process, and some of those dead ends for an individual may not be a dead end. It may be what they're looking for. It wasn't what I was looking for. I have flip-flopped so many times on the construction method that even I sometimes question which way I will go once stated. Most of that comes around how the dome is constructed. There are effectively two methods. No doubt there'll be others, or the way you like to think of them, but there is a hub and strut design, the one which I enjoy the most to look at, and then there is the individual triangles that are constructed together to form the dome. Some where you actually take the struts themselves, you can split them, create the angles required, screw them together, and they form a dome. And then there's going to be a similar but different method, the one that I'm thinking of using, where you take individual triangles without the angles cut into them, and you construct it in a manner that allows them to create a dome, which you'll see perhaps if you persevere and go through to the later dome videos. But trying to keep this short, just as the preamble, and I think it wise for people to take into consideration the fact that I'm making it, because, well, you'll see when I put the full set of videos up, there's lots that you may wish to peruse rather than study, let's say. But we started out trying to understand dome geometry, and I give a big thanks largely to Paul Robinson. He has been an invaluable source of information, and his technical knowledge and practical application of said knowledge, as I said, it has been invaluable. And I see that he has up for pre-sale orders a book, one that I think you would be wise to get and study. So, cutting to the chase. We start with the 101 of all 101s for dome construction, and we look how to accurately, I'll hide Chris here, accurately, emphasizing the word accurately, draw within SketchUp the required solid shapes of the dome. That will be paramount. Now, most of the domes that you see will incorporate, most, not all, but most will incorporate hexagons and pentagons. In my version, it actually incorporates squares and hexagons, made up of the triangles, of course. But to get there, you've got to have a iterative learning process to understand, as well as you can, literally how to get there. So some of those steps have been not using the square or the hexagon based dome geometries, because I didn't know how to get there, despite watching the different videos on, I'm not even going to say on that subject, but on the similar subject, and we couldn't get there. I eventually think I've fallen across what I wanted, and this is it here. I will just drag it in, and this is where we're at with my dome design. So this is whetting the appetite. I will show the method that I have chosen, and I won't say it's the correct method, but the method that I have chosen to get here. Some small insights perhaps, and some limitations. Now, I'm a professional builder. I've not built this dome, so that caveat comes along with any of the information. However, having the background in construction, in both heavy, medium and domestic construction, I have with me certain bias or preferences, and I give those with some reticence, but I give them because I think it is relevant to building some structure such as this. I think this is quite an attractive structure. It is inherently stable compared to some that I see because of these infill panels on the base sides, and allows the dome to be a dome much easier for the average constructor. I am paranoid in a couple of areas, circling, and I'll discuss those in the different videos, and then hopefully if you've watched this video you will have, this is like a disclaimer video. If you haven't watched it, your problem, but I will strongly recommend that you do. I'm not an engineer. I make my paranoia known up front, and it all has to do with generally this area here of the dome for my understanding of physics in the building industry. Okay, so with that, I hope you get something of worth out of the video, the mini video, and can go forward with your project with a little bit more background information, and hopefully shorten the process of learning how to build a dome like this. So with that, I'll bid you goodbye, and I will see you hopefully in the next videos. Okay now, see you later. Bye.